All right, number 47. This one's a little faster, a little easier. At 100 degrees Celsius, K sub C equals 0.078 for the reaction. SO2, Cl2 in equilibrium with SO2 plus Cl2. In an equilibrium mixture of the three gases, the concentrations of SO2, Cl2, and SO2 are 0.108 molar and 0.052 molar, respectively. What is the partial pressure of Cl2 in the equilibrium mixture? So we're already at equilibrium because it says in an equilibrium mixture. So we know we're already there. So we don't have to do an ice chart because we don't have initial values. We only have equilibrium values. So we can go right to our equilibrium expression where we have SO2 times Cl2 over SO2Cl2. Now if I substitute, K sub C is 0.078, SO2, respectively, remember this one goes here, this one here, is going to be 0.052 molar. We don't know the concentration of Cl2, that's what they're asking for, or almost, and SO2Cl2 is 0.108. So if we rearrange this and solve for Cl2's concentration, the concentration of Cl2, I'll move this over here, is going to be 0.16 molar. And I'm confident you can rearrange that and do that yourself. So from here, we now want to find the partial pressure of Cl2. And again, we can find partial pressure using the ideal gas law relationship. So the partial pressure of Cl2 is based on its molarity, universal gas constant, and temperature. We know that N over V here represents moles per liter. That's the molarity. We already found that in our last step. So 0.16 molar, which is moles per liter. That's N over V times R wrong problem. And we have 100 degrees Celsius, so that is going to be in Kelvin, 100 plus 273, 373 Kelvin. And here your pressure works out to 5 atmospheres. Okay, last problem. For the reaction I2 plus Br2 in equilibrium with 2 IBr, your K sub C is 280 at 150 degrees Celsius. Suppose that 0.500 moles of IBr in a 2-liter flask is allowed to reach equilibrium at 150 degrees Celsius. What are the equilibrium concentrations of IBr, I2, and Br2? So in this problem, they start by giving us your equilibrium constant and saying that we have an initial amount of our product. Since we're given an initial amount of product here, but they're asking about equilibrium values, we have to do an ice chart. Okay, so we know that IBr, we have 0.500 moles of it in a 2-liter flask. So it's going to be 0.250 molar. That's initially what we have here. And I'll leave units out for simplicity. We're not given any other information about I2 or Br2, so we can assume those start initially at 0. And that's all we have for this problem aside from the K sub C value. So using algebra, we're going to create relationships using variables. So we know that if my reactants starting at 0, they can only increase. And my product is going to decrease. So we have to figure out in what ratio they will increase and decrease. Since the reactants are 1 to 1 and the product is a 2 here, that is the ratio in which they will change. So we use the variable 1x. For I2, it's going to increase by that amount. And since Br2 also has a 1, it's going to increase by 1x. And since it's a 1 to 1 to 2 ratio, IBR is going to decrease by 2x, double the amount of the others. And now for equilibrium, I just do the mathematics. So 0 plus x is x, 0 plus x is x. And my decrease here is 0.250 minus 2x. Now to find what x is, because the question is asking what are the equilibrium concentrations, so ultimately I'm looking for these values for equilibrium. I need to plug these into the equilibrium constant expression, which is IBR, concentration of it, squared over I2 times BR2. Now if I plug in, my numerator is this binomial 0.250 minus 2x. It is squared over I2 is x, BR2 is x. And this is all equals K sub C up here, 280. Now, at the bottom here, I have x times x, which is x squared. In the numerator, I have a squared value. So if I take the square root of both down here, I just cancel out those squares. It's about 16.7. Okay, and now I simplify and solve for x. So multiply both sides by x. I get 0.250 minus 2x equals 16.7x. Add 2x to both sides. Now I'll go down here. I get 0.250 equals 18.7x, excuse me. Divide both sides by 18.7. And x is, I think it's 0.0133. And now we plug that in. So here, 0.0133 molar is that x. 0.0133 molar is this x. You plug it in here and get 0.223 molar for that one. All right, gentlemen, hope these helped. Adios.